Example: apply the simplex method to solve the following linear programming problem. Maximize z equals to 30x1 plus 23x2 plus 29x3 subject to 6x1 plus 5x2 plus 3x3 less than equal to 26. 4x1 plus 2x2 plus 5x3 is less than equal to 7, and x1, x2, x3 greater than equal to 0. Equation 1. Also write the solution of the dual of the above problem from the final table. Solution. Let us introduce the slack variables x4 and x5. The given constraints reduced to the following equalities: 6x1 plus 5x2 plus 3x3 plus x4 equals to 26, 4x1 plus 2x2 plus 5x3 plus x5 equals to 7. Taking x1 0, x2 0, x3 0, we have x4 26 and x5 7, which is the starting basic feasible solution of the given primal problem. And so we have the starting simplex table: Cj 30, 23, 29, 0 and 0, yb, cb, xb, y1, y2, y3, y4 beta 1, y5 beta 2, y4, c4 is 0, xb 26, y1 6, y2 5, y3 1, y1, y4 1, and y5 0, y5 c5 equals to 0, xb 7. Rest of the entries are these: 4, 2 and 5, plus x4 is 0 and y4 is 0 and y5 equals to 1. Z equals to cb into xb equals to 0, xj equals to 26 and 7, delta j equals to 30, 23, 29, 0 and 0. Most positive element is 30, delta j is 30, so this is key row, key column, and the key element is minimum ratio 26.6 and 77.4 is the minimum ratio. So y1 will enter and y5 will comes out, because here delta 1 is c1 minus z1 equals to 30 minus 0 into 6 minus 0 into 4 equals to 30, and delta 2 equals to c2 minus z2 equals to 23 minus 0 into 5 and minus 0 into 2 equals to 23. Similarly, delta 3 is 29, delta 4 equals to 0 and delta 5 equals to 0. Also, all the delta j for j equals to 1, 2 and are greater than the 0, so the positive improvement is impossible. And also, as the value of the delta 1 is maximum, so the vectors y1 enters the basis of the yb. Now we shall find the vectors of the basis yb should leave. For this we compute minimum xbj upon yjk and yjk greater than 0, where j equals to 1, 2 and k equals to 1. Now xb1 upon y1 is 26 upon 6 equals to 13 upon 3, and xb2 upon y21 equals to 7 upon 4, and the minimum of these 7 upon 4. So xbr upon yr1 equals to xb2 upon y21, which implies r equals to 2. Therefore the vector b2, that is y5, leave the basis yb and leading element is 4. As we have last table we have seen, 4 is the key element, so we will make this column in place of 4 unity and the rest of the entries is 0. So we will get the next table as follows. Now proceeding in the usual way, we have the second simplex table as follows: Cj 30, 23, 29, 0, 0, yb, cb, xb, y1, b2, y2, y3 and y4 b1 and y5 y4 c4 0 31 upon 2 0 2 9 upon 2 minus 9 upon 2 1 and 3 upon 2 y1 as the y1 is entering in the table in place of y5, so c1 equals to 37 upon 4. In place of 4 there is 1, we make 1 and the rest entries by suitable multiplication. 1 upon 2 5 upon 4 and 0 and 1 upon 4, and z equals to cb into xb. 210 upon 4 equals to 105 upon 2, xj equals to 7 upon 4 and 31 upon 2, delta j 0 8 and minus 17 upon 2 and 0 and minus 15 upon 2. Next rest of the question we will do in next video.